Thanks for joining us for part 5 of the Understanding Alarm Trips video series from More Industries. In part 4, we started our journey with alarm trip relay responses. You learned how normally open and normally closed contacts behave, and how single pole, single throw, single pole, double throw relays support everything from basic alerts to complex multi-step responses. With those fundamentals covered, let's take the next step and dive into more alarm trip relay responses. In this video, we examine how alarm trips behave beyond simply turning on and off. We'll cover important features such as failsafe versus non-failsafe operation, how they work with normally open and normally closed contacts, as well as deadband settings, latching and non-latching alarms, selecting the correct contact rating, and time delays. These settings make all the difference in getting reliable, accurate alarm responses. Let's start with an important alarm trip setting: failsafe and non-failsafe configurations. In safety-critical applications, it's not just what the alarm detects, but how it behaves during a failure. When you want to activate the same alarm state upon power loss, you define the alarm as failsafe. The relay of a failsafe alarm is energized during normal operation and de-energizes when the process exceeds the trip point or if power is lost. That way, a power failure triggers the alarm just like a real process upset would. In a non-failsafe setup, the relay stays de-energized under normal conditions and only energizes on alarm. But if power is lost, the relay cannot energize, so the alarm won't activate, making it riskier in safety applications. That's why failsafe is the standard choice in most process environments. You can combine failsafe or non-failsafe configurations with normally open or normally closed contacts to fine-tune your alarm response. Take a non-failsafe single-pole double-throw relay. It's de-energized in normal conditions and energizes on alarm, switching from normally closed to normally open. Now consider a failsafe relay. It's energized during normal operation and de-energizes on alarm or power loss. This setup is preferred in safety applications because it still triggers an alarm if power is lost. Deadband is a key feature that protects the relay from excessive wear. When the process variable reaches the trip point, the relay activates, but it won't reset until the signal moves past the deadband range. This prevents the relay from rapidly switching on and off if the signal fluctuates near the trip point. Even a small deadband, just 1 or 2%, can make a big difference in stability and reliability. Latching alarms work differently from standard non-latching alarms. Once they trip, the relay stays in the alarm condition, even if the input signal returns to normal. The only way to reset it is through a manual action, like pushing a button. This ensures an operator acknowledges the alarm before the process continues, which is especially important in safety-critical systems where attention and accountability are key. Contact ratings of alarm trip relays typically range from 1 to 10 amps. A 1 amp relay is fine for something like an annunciator, but controlling a motor typically calls for 5 amps or more. For even higher loads, like pumps, you'll need to use an interposing relay. 2 precautions are critical. Never exceed the relay's rating, even briefly, and always consider the type of load. Capacitive and inductive loads can cause damage through inrush current or arcing, and motor loads can draw 5 to 6 times their normal running current at startup. Sometimes a quick spike in a signal doesn't mean something's wrong. That's where time delay comes in. With some alarm trips, you can set a delay, so the alarm only triggers if the signal stays above the trip point for a set amount of time. It's a simple way to avoid nuisance alarms and make sure you're only alerted when it matters. In this video, we discussed how key alarm trip settings such as failsafe configurations, deadband, latching, contact ratings, and time delays affect the performance and reliability of your safety system. With the right setup, your alarms can do more than signal trouble. They can help prevent it.